Here we can see the main page of the application, which is similar to that of the TMT's GUI that we will later see. On the top, we can see 3 tabs: Corpus, Models, and Word Lists, each of them referring to one of the interactive model trainer's main functionalities, which can also be accessed by clicking on the Start buttons. If we go to the Corpus tab, we can see how there are 2 different types of corpus, raw and logical. Raw refers to the datasets that we have downloaded from the data catalog, and logical to those that we have created based on a BO corpus for either domain selection or topic modeling. For both raw and logical corpus, we can see a table listing the available corpora of each type, and by clicking on any of them, we see more specific information on the right. We can look for a corpus meeting a specific condition by using filters, and we can also create new ones. We will see more details on the generation of a topic modeling logical corpus later. If we move on to the models, we can distinguish between topic models and domain models. Let's focus on the second. We can see the available models listed in the center table. And when we select any of them, we see more models detail. Plus we have access to the retrain, evaluate and curate functionalities. There are different options to create a model. We can use a source file where the positive labels are directly loaded from a file. A list of keywords. A topic selection function. Or a category name which uses a zero-shot classification model to generate that corpus. For this, we would select a logical corpus to use, and we can optionally select some advanced options. While creating a model, we will have information about how it is trained. We could also either cancel the training while it is being trained, or just hide the information and keep doing different things, since it is an asynchronous process. Once the training is finished, we could curate the model. In that case, we could sample some documents that have been classified and the expert would need to assign some labels to the documents depending on the information of such a document. Regarding the topic models, it would be the same scheme as the explanation for the domain models. But let's take a deeper look on how all the functionalities available can be accessed through the Python-based GUI of the Topic Modeling Toolbox, which we refer to as ITMT, that also offers the word lists functionalities. To start using the ITMT, we must first select the input parameters, either through the file system or the list of recent folders. The different pages of the application can be accessed at every moment through the menu located on the left-hand side. Also, the buttons on the overview section lead to each of the 3 main pages. If we inspect the corpus management page, we distinguish 2 different views, one with the available local datasets, and one with the training datasets. The local datasets here correspond to datasets that have been downloaded by the user from the data catalog and provided through the source folder. From the first view, we can select as many datasets as desired to create a training dataset. For example, we could want to create a logical corpus from Cordis and the computer science documents of Scholar for topic modeling. In such a case, we select both datasets and click on Generate Train Dataset, through which a new window opens that allows us to select all the training dataset information. We need to select the column to be used as identifier and the fields to be used as lemmas for each of the selected datasets, in addition to specifying the name, description, and privacy level that the training dataset will have. From the training dataset view, we can now see the dataset that we just created. We can select any of the available datasets for training or deletion. In this case, we will keep working with the dataset AI Scholar, which was created through the Domain Selector tool, and contains a set of artificial intelligence documents identified from the Semantic Scholar dataset. If we click Train Dataset, 2 consecutive windows will appear for selecting the preprocessing settings, as well as many lists of stopwords and equivalences that we want to use for the generation of the training corpus. Once the latter is closed, the training window, from which we can select the topic modeling algorithm to use for the training, as well as the training parameters and the topic model information. Regarding the training parameters, we have a set of basic settings, and some other advanced settings that are only shown if the user requests them. In this case, we will use Mallet as a topic modeling algorithm, and use default settings for the training. Once the topic model has been created, the training window is closed, and we can go to the Models Management window to visualize its information, evaluate it, or edit it through the topic curation tools. The models are hierarchically listed. We can see the model AI trial that we just created, as well as others that we have available that have already gone through some curation. By clicking on any of the models, its information is displayed below, including the size of the corpus, the label assigned by the automatic topic labeling system, and the chemical descriptions of each of the topics. We can make a copy, rename, or delete the selected model. Additionally, we can edit and inspect the model by clicking Curate Model, which gives access to a new view. At the top of this view, we can see the topic size, labels, and chemical description. In the middle, a set of buttons that give access to the distinct curation tools. We could manually modify the labels assigned by the automatic labeling tool. We can look for similar topics, based on either if they co-occur with relative frequency, or if the words characterizing them are the same. Based on the similarities found, we can choose to merge some of these topics. Also, we may want to sort them according to size. Or delete some of the topics. On the bottom, the PyLDAvis representation of the model is shown, which can be expanded through the Expand PyLDAvis button. If any of the changes made do not meet our expectations, we can always reset the model to its after-training state by clicking Reset Changes. To create a Level 2 model, as the ones visualized above for the Scholar AI Mallet 5 Topics model, we just need to select the topic to be expanded and click Train Submodel, which will open a window similar to the one we just saw for the training of Level 1 topic models, but with additional parameter options. Regarding the word lists management page, it allows us to visualize all available word lists. We can inspect any of them, as well as edit or delete them. For example, we could modify the list of AI stopwords based on some new ones found.